Hi, I'm Purnima, and as a part of my assignment, I will be describing how this project and all of this code really works. And talking about the data set, Alzheimer's disease data set is a data set of health related with 149 patients' data in order to predict whether the patients are diagnosed with Alzheimer's disease or not. So going through the code, first of all, pandas as PD is used for numerical computations, and then numpy as np is used for numerical computations, and seaborn as sns is used for advanced data visualization, where matplotlib.pyplot as plt is used for basic data visualization. and then and then this pd dot read csv reads the CSV file here named Alzheimer's disease data.csv, and this is the from path content. And here the data frame df stores loaded data set as a pandas data frame, and df.shape is used to determine data uh, set size. Then after df.column, this command returns the all the list of column names of the database, and here I have all the column of my dataset that counted to be 35 in total. And then df dot is null sum. This command checks for missing or null values, where df is null. This code returns a boolean data frame true or false, and then this sum counts the number of true values or missing values for each column. And here so after running this here, uh, in output all the columns shows 0, means there is no presence of null value in any of my data columns, and the data type is int64. Then this df.info command provides a summary of dataset, including data types like int and float, and then non-null values and many others. Here df describe this command generates summary statistics for numerical columns like the total count, and then its mean, its standard deviation, minimum value, then first quartile, then median, then third quartile, and at last max or maximum value. Then the df dot head, it displays rows of data set, and here df dot head 12 displays the first 12 row of data set. Here q1 means the value below which 25% of the data falls, and q3 means the value below which 75% of the data falls, and IQR or in quartile range, it measures the spread of middle 50% or median of the data. And then the lower bound, lower bound and upper bound means any value below lower bound or upper bound is considered as an outlier. And here the outlier indices and the outlier column, they find all indices where values are outside the IQR range or in quartile bound range. And then here the outlier detect outlier IQR and other. It here outliers detection outlier IQR calls function and stores outlier indices in the outlier dictionary. And here for call indices in outlier items, and this print function, they print number of outliers detected for each numerical column. So as you can see here, my dataset has altogether generated 12 outliers, including outliers in ethnicity, and then in diabetes, and then in depression, and then in head injury, hypertension, and many more, and also including personality changes. For visualizing the outlier, I had used matplotlib.pyplot as it is used for plotting, and then here Seaborn as SNS. As I've already explained, it provides visually appealing statistical plots. And then SNS.set style white grid, it sets white grid background like this for good readability so that it would also look attractive. And then after goals with outliers, this is the filter, this is used in filtering only columns that have at least one outlier. And then all of this plot, this SNS, and then box plot, and then all of this plot defines the figure size with width 10 and then height of 4.5, like this, width of 10 and height of 4.5. Then after SNS box plot, this um, line plots box plots for columns that contain outlier and uses set2 as a color palette. And then here plt.title, this code adds title for the clarity, like here box of columns with outlier having a font size of 10. And after that, this axis rotates x-axis label if the column are long. And then after the tight layout ensures proper layout, and after the show displays the plot. And after this, I have used suitable data for visualization with the help of COMPLOT, and then here goes heat map, and also box plot, and also at last with the pair plot, and also scatter plot, and many more. Here in train test and split, this df dot drop removes any column one or more from data frame df. Here I have removed patient id, doctor in charge, and diagnosis from my data set because patient id is a unique identifier, so we can't keep it, and doctor in charge has categorical values, and keeping there does not help the model make better predictions that might lead to overfitting. And then I have also removed diagnosis because here I have used this as a target variable that I want the model to predict, which should be separated from the feature. And for feature to be known, I stored in variable x, and for target I stored in y variable, and the one that model will predict is the target variable. Here we are using split data because the model needs to be trained one on portion of the data called xtrain and ytrain. And here xtrain prints the shape of xtrain array containing features, and shape is literally pandas data frame that returns the number of rows and columns. And after xtest prints the shape of xtest array for test set, and then ytrain prints the shape of ytrain containing target values for training set, and also ytest prints the shape of ytest array for test set. As per the result, the training feature 17, 19, and 32, the first number 17, 19 represents the number of rows or sample in the training set, and then second number 32 represents the number of feature or column in each sample. Also, the testing feature set 430 represents number of sample in test set. And then here targeting test shape 179 are number of target values on training set, and testing target shape 430 are number of target value in the testing set. And I have used or built three models: random forest, logistic regression, and then KNN model. Going into random forest, the Panda is a data frame that is used for handling data, and then NumPy for numerical operations, and then this train, test, and split is used for splitting data into training and test sets. And here, random forest classifier, it is a machine learning algorithm that is used for classification. And here, metrics like accuracy score, precision score, and recall score, and after F1 score is used to evaluate the model, and then standard scaler is used for scaling features. Here, while outlier detection, I already explained NumPy. NP is used for numerical computations, and this selects only numerical columns from dataset. And here, X contains feature except patient date, patient ID, doctor in charge, and diagnosis, and Y contains the target variable that the model will predict. And then this this line is used in splitting data into training and testing sets. And here scaling feature, a scaler was used to standardize the feature. And then this scalar fit, it calculates the mean and standard deviation that normalizes features. And then the scalar transfer X test scales the test features based on training data parameter. Here, random forest classifier is instantiated with an estimator's 100, meaning 100 decision trees will be used in the forest internally. Here, dot fit model is trained on scaled training data. Xtrain is scaled and corresponding target Y train. Then this Y pred RF model, this line, is used to make predictions on scaled test data. X test scaled, and after accuracy measures correctly classified instances in test accuracy measures correctly classified instances in test data. And then this precision uh, correctly identifies positive diagnosis. And here average weighted is an option that averages the precision. And then recall, it is used to find all positive diagnoses. And then F1 score, it is harmonic mean of precision and recall that provides balance between these two. And this is nothing but all about printing the result. So as per the result, accuracy output say that 93.72% of the prediction made by model are correct. And also on precision, when model predicts a positive diagnosis, it is correct 93.72% of the time. And recall model correctly identifies 93.72% of actual positive diagnosed. And then F1 score is a balanced measure of precision and recall that shows the model has a strong balance between two metrics, that is 93.6%. Here, logistic model is used for binary or multi-class logistic classification problems like our data set Alzheimer's disease data. Dot fit trains logistic regression, and dot predict generates predictions for the test set data. And as talking about accuracy, precision, and recall, and F1 score, it is as same as the random forest, where accuracy measures correctly classified instances, then precision correctly identify positive diagnosis, and the average weighted, it helps in averaging precision. And then recall, it is to find all positive diagnose. And F1 score is a harmonic means of precision and recall, providing balance between the two. So the output of logistic regression accuracy implies that 81.63% of prediction made by model are correct, and when model predicts a positive diagnosis, it is uh, correct 81.60% of time, and recall model correctly identifies 81.63% of actual positive diagnosis. And then FOS score is a balanced measure of precision and recall that shows that the model has a strong balance between the two metrics, 81.61%. So it also comes under balanced model. KNN model is used for classification that classifies data points based on the majority of class um, of their nearest neighbor in the feature space. Here, n neighbor or K5 means that algorithm will look at 5 closest training data points to test data point and use the majority class among them to classify it. And dot fit is used to train KNN model on scale training data where precision is used, or predict dot predict is used to generate predictions for the test set using trained KNN model. The accuracy measures correctly identify positive, and accuracy measures correctly classified instances in test set, and precision here correctly identify positive diagnose. Recall, it is used to find all positive diagnose. And lastly, F1 score is a harmonic means of precision and recall that provide the balance between the two. And the result of KNN model accuracy implies that 70.7% of prediction made by this model are correct. When model predicts a positive change, it is correct 69, approximately 70% of the time, that is precision. And recall model correctly identifies 70.7% of actual positive diagnose. And F1 is scored to be 68.63%. Analyzing all the results of three models, I came to conclusion that Random Forest is best performing model with 93% of its accuracy, precision, recall, and F1 score, where logistic regression also achieved 81% of accuracy, maintaining a strong balance between precision and recall and F1 score. Here in KNN, I have considered KNN model's accuracy as balanced despite its lower accuracy of 70%, as it exceeds the minimal threshold of 60% for the underfitting. And for the recommendation, I would recommend Random Forest to use because it is the best model with 93% of accuracy, high precision, recall, and F1 score, and it effectively handles complex patterns and data like that of Alzheimer dataset that reduces overfitting and ensures stable performance across different data distributions. However, logistic regression is also a good alternative if someone need a simpler and interpretable indices.